So thank you guys for coming out in person. Thank you out in Zoom land. I will try and speak this way and this way to both of you so you can all hear. Are we recording, Brett? We are recording. So if you have to step out or you miss part of it, all of this will be recorded for prosperity. I appreciate all of you who came out tonight. Either you are really excited, like me, about heat pumps, very excited about heat pumps, or you are really excited about vegetarian vegan paella, because I'm telling you that the simple Spanish food truck is above average by far for a food truck. Really good stuff. So if you haven't gotten anything, or take some home to your family. There's also drinks at the distillery. You can go inside and order. They are having Easy Treesies, which is a drink that partners with A20, and some of the proceeds from that drink goes to help plant trees for lower income individuals in areas with low tree canopy in our city. So if you feel like an Easy Treesy, please, allow yourself. Uh-oh. Are we having issues? Okay, so anyway, I'm Julie Roth. I am a Senior Energy Analyst for the Office of Sustainability and Innovations at the City of Ann Arbor. We have a bunch of OSI staff over here as well that have helped pull this off. Yes. And the amazing Marcus over here, who did this IT magic and is also like the best dressed guy I've ever seen. And so anyway, thank you for coming and thank you for being on Zoom, and I'm hoping this is all going to work out well. So I'm not going to stand here for very long. I'm just going to remind you all that A20 is Ann Arbor's commitment to becoming carbon neutral in a just and equitable way by 2030. And we can't get there without talking about electrification. We have a big problem in our buildings, and that is that we are burning fossil fuels in them for heat. So you all know that, which is why you're here to talk about heat pumps, which I'm really excited about. So I'm going to bring up, where did Brett go? Oh, Brett Little. Oh, good. Okay, so I'm going to bring Brett up here. Brett Little is from the GreenHome Institute. They have been an amazing partner with Ann Arbor. I'll let Brett tell you all about GreenHome Institute and what they do. We also have Mike from Mitsubishi and Tim, who just flew in from St. Louis from Ream. I think he had like a plane that was smoking, and then they had to turn around to get him on a new plane. And oh my gosh, you're here! Thank you. And we also have some folks who have experience with heat pumps in their homes. And so we're going to run through all those things. We're going to have plenty of time for questions at the end. So I think what we'll do, especially with the Zoom world, is hold our questions till the end. In Zoom, you can write your questions. We have the amazing Zach, who you can't see because he's behind you, who's going to be curating your questions, and we'll feed them all up here at the end. So thank you, and here's Brett.
Thank you, Julie. Hey everybody, hey everyone out there in the real world and in Zoom world. Yeah, my name's Brett Little, and I am the program manager at the GreenHome Institute. This is my first in-person event since I think January 2020. So very excited to be sharing it with you all on this very important topic about electrification and heat pumps. So the GreenHome Institute, our mission is to empower people to make healthier and more sustainable choices in the places we live. And we're headquartered in Grand Rapids. We've been around for 20 years now, celebrating our 20th year. And with our mission, we talk a lot about the 5 pillars of green building: energy, health, materials, water, and place. And so specifically when it comes to electrification, we're talking about impacting the not just the energy conservation and efficiency and carbon reduction of our homes, but having a healthier home and a healthier space, which is very important. And so they really go a long way using air source heat pump technology to do that. And really, I did this myself. I went fully electric in my house just about a year ago. And I'm over on, like I said, just outside of Grand Rapids. And I kind of want to talk a little bit about that before I hand it off, and then what process I use to do that we encourage others to use. And so really a big part of that process is having what we call a green home inspection done, an energy audit done, a home inspection done, and just getting an assessment of what is happening in your house and then what you can do to make improvements to your house from an energy efficiency and a health standpoint. And then making sure that you're incorporating electrification and heat pumps into that conversation of improvements, because a lot of times those improvements just circle back to sealed combustion gas furnaces, sealed combustion gas water heaters, and some basic updates. So you want to make sure that that's part of the process and the conversation. Having a heat load calculation done, making sure you're right sizing your system, your heating system is very important. So if you're working with a heating and cooling contractor, you want to make sure they're using that heat load calculation approach to make sure you have a right size system, that they're using a ideally certified manual J version 8, which sounds very nerdy, but it is an official way to do a heat load calculation in some ways to make sure it's done right. And then the bidding process, again, making sure you're interviewing your contractors, they understand electrification, they're interested in it, perhaps they've done it before. Using diamond contractors from like Mitsubishi, and Mike's going to talk about them, helps with that process. And then also my good friend Nate Adams, who's now used to be in Ohio, down in West Virginia, has set up a whole process called HVAC 2.0, or maybe the fun version is Badass HVAC. And he wrote a great book, and he's got a great process laid out for electrification of our homes. And so take a look at his home comfort book and what he's doing when you're putting your project together. Highly recommended. And we've had him on before. So I'm here, I'm alive. We had a heat pump, no backup resistance, Mitsubishi in February this year. Remember what happened in Texas? Everything got really cold. It was super cold here too, and we made it through. And our energy bills weren't more than they should have been. We didn't freeze to death in our house. We were able to pull heat out of the air, and so it was amazing. And so we know it works. It was installed right. It was done right. And we use way less energy, especially over the summertime compared to our old air conditioning system. So we know that these systems work and that we know they function right. And then my Rheem heat pump water heater I had installed back in 2018, no noticeable difference from switching from a gas unit to an all-electric heat pump unit in my energy costs or usage. And the systems work. They work well. They don't cool my house down. And so again, the water heater, the HVAC side, we know that these things are working. We're recommending them as an organization as we educate people to be better. The reality is we can't go totally net zero when we're burning fossil fuels. We can't decarbonize, so we have to move towards electrification, and so that's why we promote that. So we do tons of educational webinars on Wednesdays. I actually did one today and then hauled over here at full speed right afterwards. Bad planning. But we stick to our Wednesdays, so you can check us out on our website. We do lots of stuff at greenhomeinstitute.org in regards to webinars on all sorts of topics, heat pumps, other ways to make homes healthier and more energy efficient. And I guess I'm allowed to say that in Ann Arbor, coming up at some unspecified time, but hopefully within the next year, we're going to be launching our second ever Biggest Loser competition around home energy and health and water conservation. And so the whole idea is to weigh in at the beginning of the competition with how much energy you're using, and then weigh out at the end of the time frame that we set. And the person who saves the most energy is going to win big. We're going to win some big bucks or something, so we'll see. And so we'll have energy auditing at the process of that, as I talked about. And pro tip, if you go electric, you're going to have a better chance of winning, and there might even be an electrification category. So stay tuned for that. I'll be back for that, and we're all going to lose, right? We're all going to be big losers. So at this point, I'm going to hand it off to Mike Schaefer, who I didn't give any notice to, and now he has to scramble over here. From Mitsubishi, and usually we're doing webinars with Mike, but it's good to see him in person, and he's going to take you through the most challenging process of this, right? So.
All right, thank you, Brett. Thank you. Thank you, everybody, for coming today virtually. So if I see this camera. No, that's okay. I'm just checking myself out in there if I look okay. We're all good. No, thank you for having me. Everyone hear me okay? I usually talk loud anyway, so I usually blare myself through a microphone when I start talking. As Brett mentioned, I'm with Mitsubishi Electric. I'm actually out of Chicago, so Tim flew from St. Louis, I flew from Chicago today. I didn't have a smoking plane, so that was the good part of it. There we go. We get one buddy. I was in Wisconsin yesterday and I had to give a presentation. I'm like, so I'm the only non-Wisconsin person here. And it was Monday Night Football. And the Packers played the Lions. I don't think it goes so well here. But they were all happy yesterday, and I couldn't care less. That was the only person I know. But yes, we are going to talk about, for the next, what do I have? An hour and a half? 2 hours? 45 minutes? All right, 45 minutes. For the next 45 minutes, we're going to talk about, while it's not the most difficult part of electrifying a house, it's usually the one that's the biggest hurdle to get over, is electrifying the home's HVAC system. Pardon me, I'm always used to giving presentations with slides, so I have my notes here that I'll be reading off of, so I can keep on track and don't meander too much. I get to ask this question a lot. I give a lot of presentations in terms of how to build a new home, all electric. First of all, I put a lot of focus on that, but then also a lot of work on electrifying and decarbonizing existing homes, right? Existing homes, whether it be single family, multifamily. So I say, Mike, how do you electrify a home's HVAC system? It's not hard, but I kind of break it down to 3 rules. I try to abide by 3 rules when we look at how to electrify a home's HVAC system. Rule number 1 is make sure we choose the right technology. So we'll talk about that because there are a lot of different electric heating systems that are out there. There's a lot of different heat pumps that are out there. So we'll talk about the right technology. Number 2 is addressing the home's envelope. So we'll spend a little time talking about, towards the end, what I mean about addressing the home's envelope and why that's important to electrifying a home. And then number 3 is making sure that the design of the HVAC system is critical. It's crucial to how well this heat pump is actually going to operate in the home. So those are kind of the 3 things that we'll go through, and we'll dig through some technology and some other information as well too as we get through it. But we'll keep going back to those 3 things. First off, who knows what a heat pump is? All right, if someone would like to take no, I'm not even going to ask. No, I'm not going to ask. I know, I started going on a path, I changed my mind. Everyone here has a heat pump in their home. Are you aware of that? That everyone here has a heat pump in their home. Can someone tell me what the heat pump is in their home? Refrigerator, right? Everybody has a heat pump in their home already, which is a refrigerator. So how does a refrigerator work? If you buy a refrigerator and you plug it in and let it run for 4 hours and open the door, or like when I do when I go into a hotel room and open the door of the refrigerator, it's not ice cold in the refrigerator because it's not really doing anything. How a heat pump works, how a refrigerator works, is when you put the food in the refrigerator has a compressor that is extracting the heat out of the mass, right? Out of the food, and then it is exhausting it outside of the refrigerator. So if you feel in the back of a refrigerator or below on a refrigerator, you feel warm air coming out. That is a heat pump. That's exactly what an air source heat pump is doing as well too, except for that it's removing heat from the air outside. Now there is always heat in the air outside. Always. Unless you were at absolute 0, and we wouldn't be here to complain that our heat pump wasn't working at absolute 0 because we'd all be dead. But there's always heat outside. Always. And that's what a heat pump is doing. A heat pump is extracting the heat from the air outside, and it's using the compressor in the heat pump, and it's using refrigerant, and it's essentially transferring that energy back into the space. It's an air conditioner in reverse. Because that's what an air conditioner is doing in your home. It's extracting the heat from inside the house and expelling it outside of the house. So a heat pump is just an air conditioner in reverse. Now the big difference is, what is a cold climate air source heat pump? Because that's what we have to talk about. That feeds into choosing the right technology. It's a cold climate air source heat pump. Mitsubishi as a manufacturer and every other manufacturer has standard air source heat pumps. A standard air source heat pump is going to be able to remove heat from the air outside at 100% of its capability down to about 47 degrees. So not really cold, 47, it starts to kind of taper off from there. It loses its ability to remove heat. It can still do it, but it doesn't do it as well, and it doesn't produce as much heat below that. So a regular air source heat pump is not the type of heat pump that we're going to want to put in our homes here in Michigan. Right? It gets colder than 47 degrees. That's not what we want. We still sell a lot of those for homes that already have an existing heating system that we're looking to add air conditioning to, do some heating in the spring and the fall, or in warmer climates where you just don't need a cold climate air source heat pump. So what a cold climate air source heat pump is going to do is going to continue to remove that heat outside at 100% of its heating capacity, and I'll use our Mitsubishi numbers because that's what I can speak to, 100% heating capacity output all the way down to 5 degrees. We have some systems that are -5 right now, but the majority of them are still 100% capacity at 5 degrees. Okay, better? I'll hold it right up. 100% capacity at 5 degrees. So that means that heat pump is producing as much heating all the way down to 5 degrees as it's doing today at, what is it? It feels like it's about 5 degrees right now because we're not used to it, but it's like 60 degrees or 58 degrees. So it's producing all of its capacity all the way down to 5. So what happens at 5? It just starts to lose a little bit of its capacity. If you look at all of our equipment on average, we still maintain about 82% of our heating output all the way down to -13. -13 is where we rate our systems down to. It's not where they stop operating. It's just a rating threshold for us. So 82% capacity all the way down to -13. That's -13 ambient air temperature. That's not wind chill. Like I said, it feels like it's about 5 degrees on now. It's because that wind is blowing on us. But in reality, the ambient air temperature is whatever somebody said it was, 50 something degrees outside. That's what we worry about. So ambient air temperature of -13, we're still producing upwards of 82%. We have some systems that are producing 93% of their heating capacity all the way down to -13. How cold does it get on average in the winter here in Ann Arbor? I know, but I'm going to ask. Anyone have a guess? January, February, what an average low is? I'm sorry, I didn't hear that. The low, average low. 16 to 17. Yeah, I mean January and February. 16 to 17 is the average low. The average. We always remember the record lows. We always remember those. I remember the polar vortex when it was, -24 for 3 days in Chicago. I remember that. But the average low in January and February is 16 to 17 degrees. On an average of 4.5 nights a year, it dips below 0 here in Ann Arbor. Only 4.5 nights a winter does it actually dip below 0. So what's happening at our systems, our cold climate air source heat pumps, when it's 16 or 17 degrees outside? 100% heating capacity. You have no loss whatsoever. What's happening when it's 0 degrees outside? You might have a little bit of loss on our system. So we're able to provide, with a cold climate air source heat pump, extreme heating output all the way into the deep negative temperatures. So we always remember the coldest days. We always do. I do. I know everyone. You remember the hottest and the coldest days because that's what sticks in your mind, right? You don't remember on average, we're really not that cold. We spend the majority of our time here in the 20s and the 30s in the coldest winter months. So it's really not as cold as what we think, but we need to size for those coldest days. And that's what Brett was talking about with manual J load calculations and things associated with it. What about efficiency? How do we rate electric heating? Anyone tell me? How do we rate electric heating? Coefficient of performance, that's a COP. So if you see anything that is an electric heating source, the efficiency rating for that is a COP, or it's a coefficient of performance. How to understand what that is? If we think of electric resistance heat, so that would be like an electric baseboard, a plug-in space heater, a toaster, anything that's electric resistance heat has a COP of 1. That means that for every $1 you put in, you get $1 of heat out of that system. That's a COP of 1. A COP of 1 is 100% efficient. There's no loss on it. So electric resistance heat is 100% efficient. It's the most efficient type of heat you can really get. However, it costs a lot of money to operate. That's the difference with electric resistance. While you get every $1 you put in, it costs a lot to produce that kilowatt of electricity that it's producing. Air source heat pumps have a higher COP than that. So you think 100% efficient, how can I be higher than that? Well, you can exceed that efficiency of the COP standpoint. We have in our air source heat pump COPs in 2, 3, and the 4s. So if you have a COP of 3, that means that it's 300 times more efficient than electric resistance heat. So every $1 you put in for that heat pump, you get $3 worth of heating out of it. So it's extremely efficient from that end. When you compare that with a natural gas system, what's the most efficient gas furnace that's out there now? 98%. So even the most efficient gas furnace is not 100% efficient, right? For every dollar you're putting in, you're getting 98 cents of heat out of the system. So from an efficiency standpoint, air source heat pumps are much more efficient than anything gas related that you could possibly put in. The difference is operational costs that you have to look at, and that's always driven by utility costs. So that's where utility costs come into play. We're always more efficient, but operational costs are going to be in relation to utility costs. So there's gas per therm costs and there's electricity per kilowatt hour costs. So those are the things that tie into operational costs. But efficiency wise, much more efficient than gas furnaces. We did a study, and this is something I could share with Brett that we could share out if we want to share this. But this was a study a couple years back. I want to say it was 2018 that was done with CEE in Minnesota in the Twin Cities. So this was a study that CEE did independently just using our equipment, but they were looking to validate cold climate air source heat pump technology in a cold climate, which is at Twin Cities, which is colder than here. So I always like to use that when I talk. Wherever we're going to do it, Minnesota is a good place to do cold climate air source heat pump studies. What they looked at were two structures. So they had, one was a duplex, new construction, so 2016 construction, and another one was an old 1920s leaky bungalow style home. They had gas furnaces and then regular single stage unitary air conditioners in there. What they did was just remove the existing HVAC equipment, so remove the furnace, remove the air conditioner, and installed a single zone air handler, cold climate air source heat pump, and did nothing else to the home, nothing else to the ductwork, nothing else to the systems at all, just an equipment swap to see how effective this system actually was in the winter. Now, these air handlers that were put in were matched with a cold climate air source heat pump. They had backup electric heat kits on them because this is Minnesota and it does get colder than 0 degrees up there. It gets quite cold. So they wanted to have that backup heat because one of the part of the study was to see how often did that backup heat actually engage, right? What was the usage out of that and how efficient was the system? So within the two homes, I just remember some of these numbers. Some of them I don't. But in the new construction duplex, only 90 or 98% of the time that electric heat kit never engaged, which meant that the air source heat pump handled 100% of that heating load in that home throughout the Minnesota winter. Only 2% of the time did the electric heat kit engage. The air source heat pump never turned off. The electric heat kit just engaged 2% of the time to supplement some needed BTUs in the space to keep them at their space temp. Because we did not want them to alter their usage at all. Don't change anything. Don't change your living habits, anything whatsoever. So if you keep it set at 70, keep it set at 70. It's only 2% of the time the heat gets turned on to keep it at 70 degrees. And the other house, it was 8% of the time the heat gets turned on. But once again, the heat pump never turned off. It was an older leaky home. We also noticed that they did deep setbacks twice throughout the day, which meant at night they set their thermostat way back. And then when they woke up, it had to recover. And when they went to work, they set it way back. So when they came home, it had to recover. During those recovery periods, the heat kits were turning on to try to recover it. But we didn't want them to alter their living circumstances. So that had something to do with the heat kits as well. But the big thing with the study showed that not only was it viable, because the heat pumps never ceased operation and they kept set point with a little bit of assistance in the coldest days of the year, it was also averaging a seasonal COP around 2. So throughout the heating season, it averaged a COP of around 2, which means it was about 200 times more efficient than just straight electric resistance heat, which meant it was viable. I'm sorry, 2 times. More efficient than electric resistance heat because it was viable versus that. So very, very comparable versus natural gas in a colder climate. Let me refer to my notes here for a second. Another thing when it comes to the right equipment is talking about inverter compressors. Does anyone know what an inverter compressor is? Do you know what an inverter compressor is? No? All right. I know Greg does back there. So an important thing with this technology is inverter compressor. And anything that you're going to look at with a cold climate air source heat pump is going to be an inverter compressor. And it's a big thing in relation to efficiency as well as comfort. So in most cases, I can venture to say in most people's homes here that the air conditioner, if you have central air conditioning, it is most likely a single stage air conditioner, maybe at best a 2-stage if you have that. But in most cases, it's probably a single stage air conditioner that you have in your home, which means that let's say it's a 3-ton air conditioner. If that 3-ton air conditioner turns on and cooling, it's going to give you all 36,000 BTUs of its cooling until the space temperature is set, and then it's going to turn off. And then it's going to wait for the space temperature to rise. It's going to turn on. It's going to go up and down. But that's how a single stage system operates. An inverter compressor, which is key to the efficiency and the comfort of a cold climate air source heat pump, works completely different than that. A 3-ton inverter compressor is going to turn on and give you only as much heating or cooling as you need in the space. So it's modulating, right? So if you don't need all that 3 tons, you're not going to get all that 3 tons of heating or cooling that the space is asking for. If you only need 1 ton of it, you're only going to get 1 ton of it. It's going to modulate accordingly to keep that space temperature right at set point. The beauty of that is you're not turning on and off, because that is your biggest drain on electricity, is turning on. So we don't want to turn on and off. You need another one? They can't. Oh, there we go. There we go. All right. All right. Was it not working? Okay. Maybe I'm walking next to something. Maybe I'll stay over here. Okay. But the beauty of the inverter compressor then is we're not turning on and off. So you're not getting those big energy draws when your system is turning on. We're also modulating accordingly to not get these big temperature swings. So we want longer run times. We don't want to turn on and off. It's going to use less energy running that way, and it's going to keep the space temperature a lot more comfortable and consistent. It's just like cruise control versus city driving. It's the same concept when it comes to an inverter compressor, and that's key to the technology. So when I say looking at the right technology, cold climate air source heat pump, an inverter driven cold climate air source heat pump. That is crucial to putting in the right system in your home. I always tell people I could electrify any home, but I want to do it efficiently and comfortably. So those are 2 key things to it right there. Flip next. What are some other benefits of air source heat pumps when we're talking about electrifying homes? It's also the safety benefits and the health benefits of air source heat pumps. What's a downfall to a gas furnace? I'm sorry, what was this one? Carbon monoxide, right? It's a combustion piece of equipment. It's an internal combustion piece of equipment. So the reason Ann Arbor is doing all these events is we're looking to decarbonize, right? We want to get off of the reliance of utilizing fossil fuels. And that's where air source heat pumps come into play. The downfall to a gas furnace is that it's a combustion piece of equipment. So it's burning gas, it's burning flames, it's not safe, it's not healthy to do either. That's where the push to electrification comes into play. So it's health benefits from that end of getting rid of combustion. Another one is thermal comfort. This ties into that inverter compressor. When I talk about thermal comfort, especially with heating, let's think if I have a slab of concrete and I blast really hot heat on it, but I only blast really hot heat on it for about 30 seconds and then I turn it off. And then in another 2 minutes, I blast really hot heat on it for 30 seconds and then I turn it off. It's gonna take a long time for that slab of concrete to actually get warm. That's how a gas furnace actually works. It's blasting hot heat at you for a period of time and then it's turning off. And it's waiting for the space to get cold again. An air source heat pump with an inverter compressor is not doing that. It's not blasting the super hot heat, it's putting out warm heat, very warm heat, but it's doing it consistently. So it's allowing that thermal mass within the space to get up to temperature, to hold it stronger, to maintain a lot more consistent comfort in the space. So it's a big benefit from comfort. Another thing is indoor air quality. We're not burning air. There is no combustion, so that is much better for indoor air quality. Also, if we look at, and we'll talk about equipment next, type of equipment, or type of indoor units. If we talk about full air handlers, you can add on any type of air filtration that you want to that system. When I start to talk about air handlers next, think of it as very traditional from a furnace standpoint of what it looks like. You can add on any filtration. But what about homes that don't have ductwork in it? If we look at integrating ductless indoor units or multiple ductless indoor units or different types of systems I'm going to talk about, we can have multiple points of air filtration. Also with the inverter compressor, we want constant air movement within the space, which means constant air filtration as well. So there's a lot of benefits to an air source heat pump, not just getting off of gas, not just electrifying, but there's a lot of health benefits that relate to that as well. As Brett, I know he's measuring PM 2.5 and everything else and VOCs in his house all the time. Just follow him and you'll see everything of how his house is doing. But it's very important to the health of the occupants in the home as well. So now let's talk about the equipment. The last thing I wanted to cover. Since I don't have any slides to look at, I do have brochures on the back table. I probably should have handed them out first. We had them sitting out and then realized that wasn't going to work because it's a slightly windy. So Greg's going to hand some of these out here. But when we talk about equipment, we have many different types. First, we have the piece that sits outside, right? That's your air source heat pump. That's what's really doing all of the work. That's doing all of your cooling. That's doing all of your heating. That is the heat pump that sits outside of the house. Just like you would have a traditional air conditioner sitting outside, the heat pump is sitting outside. What is it connected to inside? That's where we have a lot of options. That's where it's not just as simple as a furnace. First of all, does everyone, who here has furnaces in their home currently now? Ducted homes with forced air furnaces. The majority of, I think, did anyone not have? There we go. Boiler? All right. So you're my boiler house. I'll come back to you. Everyone else that has a home with a furnace and existing ductwork, that is the easiest home to electrify because you have a central air distribution system already in the home. I have a furnace in my home still currently. It's 6 years old. Brett and I were talking earlier. I'm like, I'm not ready to do it yet because I have a 6-year-old system in my house that works just fine. So I'm not quite there yet, but eventually. Having a furnace and a central duct system in your home is the easiest one to electrify because we have a piece of equipment that is our multi-position air handler that you can remove that furnace that you have in place now and that air conditioner and install equipment right into that existing centralized duct system in your home and have no aesthetic change to anything else in your house. That is the simplest home to electrify because that indoor unit, that fan coil unit, is very traditional and similar to a furnace. What's different of it from a furnace? Well, it's not a furnace, so you don't have to worry about gas going to it. You don't have any kind of flue venting going outside, so that's one thing that is eliminated as well. It is not a combustion piece of equipment, so if you happen to have a home where you have a furnace in a closet, because a lot of people have a furnace potentially in a mechanical closet that has to have a slotted door because of combustion, you don't have to have that. With air source heat pump air handler, there is no combustion, so you can put that in a very small concealed space. They're extremely quiet. That's a big difference compared to a furnace, is the noise that you would notice. But from an aesthetic standpoint, there is no change to the house because you can utilize that central duct system that you have. So it's very, very easy to do that with a fully ducted air handler. But what about the homes that don't have a centralized duct system? That's where when you get a chance to look at the brochures, we have multiple different styles of indoor units. We call them indoor units. It's basically the piece that is being used to move the air and the conditioning throughout the house, right? One is that full air handler. The other is we have ductless units. So if anyone's heard of Mitsubishi, they probably thought of a ductless high wall unit. That's definitely our most popular that we've seen. We have ductless high wall. We have ductless low wall for applications where you can't put units high. We have ductless ceiling cassettes. So units that recess into ceiling cassette or into ceilings that recess into joist spacing. We have units that fit into drop ceiling spaces from that end. So we have a lot of different options of equipment for homes that don't have ductwork, right? We have to put some conditioned air in the space, but we don't have a way to distribute it via ductwork. We can utilize ductless systems. Now, how do you design with ductless systems? That's where it becomes crucial. Is we don't want to over-design a system. You may not have to put a unit in every single space. We have small ducted systems as well. Systems that we have horizontal style units that are this big, like pizza box size. So they're very small, compact, horizontal ducted units that maybe you have a space that you can run a little bit of ductwork off of that and hide this very small concealed ducted unit and take over a couple bedrooms or 2 or 3 spaces with it. We have those as well too. The beauty of these indoor units that we have is we have a lot of different options and they can all be mixed and matched to fit the right design. So if you have a home that has a duct system, super easy. If you have a boiler heated home, it is not difficult. It's just making sure the design is right. And that's where finding the right contractor really comes into play with that. Making sure we have someone that understands the equipment and understands sizing to get the right the right type of units in that space. But we do homes. I'm from Chicago. We have a lot of boiler heated homes, and we do just a ton of them. A lot of it may not be electrifying the home, but it's adding air conditioning to a home that has radiant boiler heat. So it can be done, and boy, we do a lot of boiler heated homes, a whole lot of boiler heated homes. Last thing I wanted to cover was the type of system. So we talked about the indoor units, but then we have single zone and we have multi-zone systems. So for the homes that have a centralized duct system, the odds are you just have a single zone system, which means you have your heat pump outside, you have your air handler inside. Homes that don't have a duct system, you're probably looking at a multi-zone system, which means you have one unit, one heat pump sitting outside, but it's connected to multiple different indoor units. So you may have one unit sitting outside that's connected to 4 different ductless units inside the space. They're all connecting back to the same air source heat pump, but now you have individual control between those, and you're able to distribute your BTUs throughout the space accordingly. Even the homes that have centralized duct systems, odds are the duct system in your home is not perfect. I know mine's not. I mean, most aren't going to be unless it's a brand new built home. There's ways to address ductwork in the home. There's products out there that can help seal up ductwork in your home. But sometimes, especially with an older home, you can't get to everything. So you still may have rooms within the house that don't get good airflow, that are hard to heat and cool with whatever system you're connecting to the ductwork. An air source heat pump doesn't fix ductwork inadequacies, right? That still needs to be addressed separately. We do a lot of multi-zone systems where we can put an air handler in for that central duct system, but then also put in another indoor unit still connected to the same heat pump for that far room on the duct run that just has a hard time heating and cooling. Or for the home office that has different use than the rest of the home. I know my wife works from home. Well, she's in the same room almost all day. That's totally different use than the entire rest of the house, right? So a multi-zone system, even in a house with a centralized duct system, can really come into play from a comfort standpoint, as well as hitting those rooms that are just hard to heat and cool. What about homes that have, or that require more heating BTUs? Again, my last topic here, which is still electrifying. Sorry about my nose. It's slightly cold out here. So, I'm sniffling a little bit. I'm not sick, trust me, I promise. What about those homes that may need more heating BTUs than what the air source heat pump can supply? So let's think about a home that requires 80,000 BTUs of heating. Let's use this home. It requires 80,000 BTUs of heating. Well, the largest single zone cold climate air source heat pump is 42,000 BTUs. Is that going to be enough to cover a house that needs 80,000 BTUs of heating? It's not. I mean, if at peak demand, it wouldn't be enough, right? There's ways to get around that. That's where addressing the envelope comes into play. How can we get that load lower? Does that mean increasing insulation, doing some air sealing in the space, addressing the envelope, maybe putting a little bit of the money first into the envelope before going to the HVAC system? That will lower your load, lower your demand on the home. It'll also save you money on your energy and your electricity bills, and you can have a smaller HVAC system in there. So addressing the load is one way to do that. Another way is incorporating backup electric heat to make up for those BTUs needed on the coldest days of the year. Another way is looking at a dual fuel system. So we have a product coming out in, Greg, where are we at now? February? I'm sorry? February. Yeah, it was January or February that we have our product coming out, which is a dual fuel cold climate air source heat pump product, which will allow you to keep a high efficiency gas furnace in place, handle the majority of your heating load with a cold climate air source heat pump, and hopefully not get blown away. Ooh. For all of you on Zoom, the tornado just blew through here. I know you said, whoa. So the dual fuel system, which dual fuel is not new, right? Dual fuel is not a new thing, but dual fuel cold climate air source heat pump is, right? So being able to handle the majority of your heating need, all of your cooling, and the majority of your heating need with a cold climate air source heat pump, and just operate that gas furnace in the extreme colder temperatures that you may need. So it's there as a backup, right? It can be there to supplement during your coldest days of the year and take over from that end. We will also have the ability to do that in a multi-zone configuration. So say you keep your furnace in, you can put our cold climate air source heat pump matched with that, operate the cold climate air source heat pump, have the furnace for backup for the home, but you still have that room that is hard to heat and cool. That can be on another indoor unit connected to that multi-zone cold climate air source heat pump. So dual fuel is still an option for the homes, that may have too much of a heating load that a heat pump can't handle by itself, or if we're just looking for a bridge product to get to that electrification, right? We're not ready to take 2 giant feet and jump right into the electrification pool with an air source heat pump. Don't be afraid about an air source heat pump. They absolutely work. You won't have any problems with that. But maybe you're just concerned and don't want to get rid of that gas furnace just yet, or maybe you still have a newer gas furnace that you actually have in your home. That's what I'm waiting for, to utilize this newer gas furnace that I still have in my house and get onto the heat pump with that. The dual fuel product will be something to help bridge that gap. I covered a lot. Are we saving questions to the end, or do you want to handle some of my questions now? Julie? Do you want to save all the questions to the end or handle some of mine now? Want to do some now? Okay. Yes. Yes. Absolutely. Great question, Julie. She asked for all of those on Zoom. Julie asked, with the dual fuel product, can we use the furnace you currently have, or do you have to get a specific furnace to utilize with it? With our product, it's universal. So you can use your existing gas furnace, or you can install a new gas furnace if you would choose to, but there is not a specific manufacturer brand that would have to match with our equipment. That's one of the beauties about what we'll have coming out. I don't want to talk. I'm not trying to project on ourselves. Greg, do you have something to tie into that? So, and I'm going to repeat what Greg said there. Or actually, I'm going to have Greg say it again. This is Greg Driscoll with Mitsubishi, by the way.
So yes, thank you, Mike. So we do have a system testing. We actually have 3 systems testing right here in Michigan, and I have one in Macomb Township. Sitting on top of an existing gas furnace, we replaced my condensing unit, put the coil on there, and it does work very well. We've heated the home for 2 years, and most of the heat is coming from the electric heat pump. So well, we have it designed, my system, to switch over at 9 degrees. So as you can tell, most of the time we said, the temperature is 16. Up in Macomb, I believe the average temperature is somewhere around 9 degrees. That would be the changeover rate. So it does a very good job. My gas furnace is actually somewhere around 12 years old. And we just changed it 2 years ago and put that coil on there. Okay? Yes. Yes. No. No. Does it switch automatically? Yes. It does what it needs to do all on its own. It's all through the system. The thermostat tells it what it needs. When the heat pump can't keep up, it'll change over to the gas furnace side. Yes. That's correct. Yes. Okay. Any more questions on the dual fuel system we're producing? Okay, it'll be out in February.
Thank you, Greg. Let me tie in that one too. Remember, it's all about sizing, and it's all about what your need is. So with our cold climate air source heat pumps, that's 100% heating output down to 5 degrees. We'll talk about the air handler one because that's the most common, right? 100% heating output down to 5 degrees. If it gets to 0, you may not need backup heat kits to turn on, the heat pump doesn't shut off and kick into electric backup if you have our heat kits on there. It's all based upon the indoor set point. So it's going to kick those heat kits on just to maintain set point. It doesn't just turn them on automatically. Like I mentioned with that study in Minnesota about the percentage of times the heat kits turned on, the air source heat pumps never ceased operation. They just turned on to supplement those BTUs throughout the space. We're seeing, honestly, the majority of the time. I have a builder in Chicago, and we just did a tour of his house with the Passive House Alliance. I think it was last week, and he's got heat kits in the house, and he's just got the breakers turned off on them. He has them there as literally an emergency backup. If he feels he's gonna, then he'll flip the breakers on and operate. They're emergency for him. Yes. So do we have a list of contractors we would approve our installation? We do. For Mitsubishi Electric, it's mitsubishicomfort.com is our website. And there is a dealer locator on that website that have all of our diamond contractors and ductless pros listed there. So these are certified HVAC contractors that are certified in our equipment to install that in your home. So it's mitsubishicomfort.com. And there's a dealer locator right on there. Great question. Now, I'll say, so great question is, if I put in a cold climate air source heat pump, air handler system, and don't put in electric backup heat, what's the cost implication to add it on later? Did I understand that? I'm sorry? And effort, right? And effort. So the cost of the heat kit is not much. A heat kit doesn't cost all that much money at all. You know, I don't know what cost to a contractor might be on that, but it's not that expensive to add the electric heat kit on there. And the actual effort is going to be more about the from an electrician side of getting power to it. So it depends on where your panel is in relation to where your air handler is at. From a HVAC contractor standpoint, there's not much effort at all because our system just sit right on top of our air handler. So it would be a matter of cutting some ductwork back if there's space, right? So that's the implication. Is there a height allowance for it? It should be capable to be done, but it's a simple installation. It's more of getting a run from the panel there to power it. So that, depending on how close that is or how easy it is, that's where the implication comes in. I think of my house, we have a finished basement, and my electric panel is on one side of the basement, and my furnace room is on the completely other side of a drywall finished basement. That's not easy. But if you have an open basement, super easy to get that run there from the panel. For the system, it's going to depend. I mean, it depends on the size of the system. So you may need a 25 amp breaker, you may need a 50 amp breaker, depending upon the size of the system. But it's all 208, 230 single phase power. It's not anything special from that end, but it's going to depend upon the size of the system that you need in relation to that. And then the electric heat kits will be another draw on top of that. That's separate. And that again is going to depend. Is that 35 amp, 45 amp? It's going to depend upon the size, right? Because electric heat kits are going to range from 3 kW heat kits up to 17.5 kW heat kits. Depends on how much backup heating you need in the space from the draw. So it's not, you got to think the air source heat pump is not much more than your central air conditioner that's in there now. Not much more of a, it's going to depend on the size again. That's where it depends. It depends upon the capacity, the size of the system. Well, right here first, and I'll go to you next. So we don't make anything specific, but if you have a backup battery system, it's going to have to be large enough to handle that load that would tie with it. We were talking about it earlier today. Yeah, if you have a battery backup system or if you have a generator from a backup system, we can work with anything from that end. It's not specific with it, so it just depends upon the capacity and the size of a battery backup you might have. I'm going to get back here first. So what is the cost difference between a furnace and air conditioner and we'll say the single zone fully ducted cold climate air source heat pump? It is extremely comparable to a high efficiency furnace and a high efficiency air conditioner. Those are the things that we have to remember. So if I take the cold climate air source heat pump I'm talking about, remember, that's an inverter compressor. So we have to be comparing it to a comparable air conditioner because it's an inverter compressor, and these are higher efficiency pieces of equipment. So when we compare this against a comparable high efficient gas furnace and a high efficiency air conditioner, it's right in line with that. It's going to be more expensive than an 80% gas furnace 13 SEER, which is your minimum efficiency furnace and air conditioner. It's going to be more than that, but it's comparable to your high efficiency furnace and air conditioner systems. Yes, perfect. Can you power with rooftop solar? You'll never be able to power it directly, most likely from the amount of rooftop solar that you have, but bringing that to the panel and to an inverter and things of that sort to get power back to the house, yeah, but it's going to probably draw more, especially in heating, than what the rooftop solar, not tying it right to it. Right, we were talking about that earlier. I know he's got a better take on this. Yeah.
Like almost 4 kW of solar and a backup battery, and in the summertime, for the most part, the solar can power the air conditioning along with my entire house and everything else, no problem at all. It's of course in the wintertime when there's less exposure, that's never going to happen. So no, and actually you could even disclude the fact I even said I had a battery. During the peak time of the day when the sun is up, yeah, you'll probably get it during that time. But yeah, because I have the battery, I can just run. I run during peak, which is 2 to 7 on consumers territory, and I run it all off the battery from the solar in the morning. So. Well, so solar, when you put it on, it first goes to your house. You use it in your house first, and then it goes out to the grid. That's typically how it works. And if you have a battery, you obviously work off the battery. But yeah, so that's you use it first in your house, and then it heads to the grid. And like I said, you could, and obviously if there's a shortfall of solar, then the grid kicks in to maintain your air conditioning. So, yeah.
Thank you, Brett. Zoom.
All right, so we've got a bunch of questions rolling in. We're gonna see how many of these we can get to in the time that we have. First one is, what kind of refrigerant is used in these, and can these systems be recharged? Will local contractors perform this service?
Standard R410A refrigerant, and yes, they can be recharged. With a system like ours, with the cold climate air source heat pump, if it is installed properly, it should never have to have refrigerant added to it again. If you're having to add refrigerant to your system, it means there's a leak and something was not installed properly, especially with ours, so hopefully you should never have to add anything. And yes, contractors can do that locally, no problem.
Forgive me, I have to scroll through all of these. Some audio trouble, so thank you everyone on Zoom for your patience. I'm glad that we got it somewhat sorted out. The question in there is, we have a tri-level split, and 4 different HVAC contractors all recommended a gas backup furnace to the heat pump. Nobody recommended 100% all-electric heat pump system. Would this be because a split level layout is not as energy efficient?
It's probably not, it's definitely not energy efficiency. It is probably, it's one of 2 things. Either they're not fully aware of our product capabilities, which is not uncommon. There's always work to do with that. Or they're just not comfortable with the layout and the design. You got a split level is tricky, so that could be a reason why. But so it's either not the product's capabilities, or maybe the load is too much for what they need. A lot of it, what we see with that, if someone's trying to talk into a gas furnace over a cold climate air source heat pump, because they're not positive on our product's capabilities, or the load is too.
Not efficiency. Not in the house. Okay. So we've got just a few more here. Do we know what kind of federal, state, or utility level rebates are available for heat pump installation?
I'm not the one to talk to that locally here for. I'm going to have Brett come and hit you up on that one. I cover 19 states, so.
Yeah, hey, Brett here. I don't know where I assume you're coming from Michigan, or at least the Ann Arbor area. you know, unfortunately, right now we have a situation where we have rebates for gas furnaces, um, but what's up? Oh, there's new information. All right, funds, money, but I think what I'm saying hopefully is still true. So I'll let you. The reality is that we can't fund fuel switching in the state of Michigan and many other states. So we have an unfair market advantage to the gas furnaces where someone could come in and give you money for that as a rebate, but not for your heat pump. It's not allowed. Now on the AC side, you can get the rebate for the efficiency, but not the heating side. So that's a concern, and we're going to be doing a lawmaker awareness day on October 7th to just give some education on this technology and why we should be able to do that. But thankful to DTE and consumers, they're rolling out a bunch of different funds, especially on the new construction side, to pay for these kinds of things and these transitions. And I know when people are trying to do backup systems like on propane, there's a lot of opportunity for funding of that, especially in income restricted housing that we're seeing over in the consumers territory. But yeah, there really isn't that much right now, but maybe there's something new that we're going to hear about. So.
Hello, so for DTE, I checked their energy efficiency webpage. So today, if you install a heat pump, if you replace your air conditioning with a heat pump, you will get a rebate of like $750 for the equipment. But it depends on what heat pump you install. They have a very specific energy efficiency requirement. So if you meet that requirement, you will get the rebate. And also, when you look at their website, you may find some language quite confusing because they say if you replace AC with an AC, you get energy efficiency rebate. But for heat pumps, they put rebate there, but there will be a line saying if it's a new installation, it's not qualified. So last year, because I installed an air source heat pump in my home, so when I applied for the rebate, it got rejection because it's a new installation. so I contact them and telling them, you know, because most family here, we have air conditioning, you know, so heat pump is something new. If you say it's a new installation, not qualified, it's most home will not be qualified for the rebate. But what I'm doing is good for energy efficiency improvement. So finally, they approved my rebate request. So I think later I also talked to some of their people, you know, regarding this, you know, the language, you know, misrepresentation. So they told me it's fine, you know, if you replace an AC with an air source heat pump, you should get rebates. So in case any of you had problem with that, you know, contact Office of Sustainability and Innovation with the City of Ann Arbor. We probably, you know, will collect the case and help you. Thank you.
Thank you. Just be prepared for rebates. I mean, you know, Illinois, Chicago, ComEd allows fuel switching now. The East Coast, I mean, if you could see some of these rebates that are hitting out there, all this stuff funnels in here. I mean, you're talking $1,200 a ton in terms of rebates. Like, this stuff is all funneling our way. It just takes a little bit of time to get to the Midwest. Wrap up. All right. Thank you very much, everybody. I'll be here.
Thanks. We see a lot more questions on Zoom. We'll see if we can get to those at the end. Thank you all for your patience.
Yep. Whoops. Hi. Yep. We'll have time at the end for more questions. Whoop. There we go. Hi. We'll have time at the end for more questions. We'll bring up all the speakers. So Brett will be up here, and Mike, and Tim, and a couple of other folks we have in the audience who have heat pumps. So if you didn't get your questions answered, you'll have time. And Tim, are you here? Oh, good. So Tim is from Rheem. I'm going to let him introduce more about himself, but Rheem makes an air source heat pump water heater, as opposed to a, you know, not to replace your furnace, but to replace your water heater when that goes. And I am really excited to hear about it and hear about the technology. And he's making his way up here, and he's got handouts. And I'm going to do a tap dance while we wait for Tim.
I can actually start. I don't really need this, but I will. Then I would ask, could you pass out to the rest? Give me a copy though, so I know what I'm talking. You got gloves on. You were smart. All right. Good evening, everyone. My name is Tim Goggin. I'm with Ream Manufacturing. You may have heard of us. Give you a little background. I've been with the company going on 28 years. There isn't much I haven't seen in this industry. And the one thing I'll tell you, as a manufacturer, we make product that represents 65% of all the energy used in a home. If you're familiar with Ream, we have a pretty significant footprint in North America, and we're global. So we have insight in regards to what the world's doing, and specifically have to keep very keen the pulse of what's here in the U.S. Now, I was excited and delighted to get on a plane, even though, like you said, the engine caught fire, to get here. Because I'm finding, as I'm speaking in regards to efficiencies and high efficiencies and heat pump water heating, that a lot of people may not necessarily understand what's all the buzz with all this, right? So there's so many factors going on right now in the world. And the one thing I'll tell you, in the U.S., we're one of the few countries that have not utilized almost extensively this type of technology. Okay? We're one of the few. In fact, as a tank-type manufacturer, tank-type water heater manufacturer, I don't know many in the world that are still using tank-type without utilizing heat pump technology. Okay? So, as I said before, we represent 65%. But a water heater in the average home is 16 to 18% of all the energy used. Okay? Now, that's gas or electric. Okay, because we do both. So I have a unique perspective, not just from the electric side. Okay? And heat pump water heating, who has heard about heat pump water heating? If I were to ask this question 10, 15 years ago, how many hands would have been raised? Very few, right? Heat pump water heating's been out for decades. So what has changed? What has changed? The technology has changed. The environment has changed. People awareness of saving energy on high efficiency products has changed. Okay? We're dealing right now in an evolving world as a result of, believe it or not, global warming. I'm really trying not to go down that road. Okay? But there are a lot of factors involved. But here in the state of Michigan, okay, whether it be consumers, DTE, whoever, you know, it all costs money to generate energy. And I think here in Michigan, didn't they just close or about to close like a coal-based energy plant? Okay, and Mike said it right. I mean, everybody's getting away from carbon fuels and things of that nature. Okay, so they're looking for alternatives. So utilities have a unique interest in saving electric load. Now, that's interesting, right? They're electric companies. They want to sell more load, right? Not necessarily the case. Because if you ever look at your electric bills, you may have different rates based on the time of year and the time of day. You have, and again, I can't speak specifically to consumers or DT because they may have a different rate plan, but you have peak, non-peak, okay? And there's different rates for that. So introducing and promoting and having incentives for high efficiency products specifically to reduce the overall and hopefully peak saves you as a consumer money, saves the utility money because they don't have to generate in you know, operation of the generation transmission plants, and everybody's happy. And it's a greener environment. Okay? So, some of the things that have come up with heat pump water heaters, I actually took the initiative to put them under some of the questions. And this is, I took the perspective from a homeowner's perspective. Okay? Heat pump water heaters don't work in cold climate. Boy, how big is that? You may have heard Julie say I came in from St. Louis. It was like 80 degrees yesterday. Okay? I'm glad I didn't wear a golf shirt.
heat pump water heaters really don't get exposed to the outside climate. They're in.
Just letting you know that the food truck, Simply Spanish, is going to leave in about 15 minutes. So if you haven't, or if you want to take home food, paella to your friends and family, they're there for about 15 more minutes. Sorry.
No problem. No problem at all. So a water heater, a heat pump water heater, is going to be subjected much like you have every home where people live have some form of hot water, right? So it really is not subjected to the outside temperature. It's subjected to the inside temperature of the home. Okay. Now I know where my wife keeps our home. I'm not happy about it, but she's saving energy. I get it. But most homes are somewhere around 65, 70 degrees, right? So that's the temperature that it's utilizing. The way a heat pump water heater works, it actually captures the residual heat of where it's installed. Now, our product, it needs 700 square feet, cubic square feet, okay? So in an environment where there's 700 cubic square feet, the heat pump will work properly, okay? Now, I didn't mention this, but they're actually called hybrid heat pump water heaters, because in the event that, for whatever reason, it's not keeping up with the demand, the elements will kick in, okay? Resistance elements, what I think Mike had mentioned earlier as well, but I'm going to get into that in a minute, okay? So another question, and you have these as well, it's too expensive. Yes, they are more expensive, but I mentioned earlier, there are incentives out there. There's a $300 federal tax rebate that applies, and we fully expect that to apply next year. And the energy saving, these products typically have a 10-year warranty. Okay, and I'm not saying that they're going to last 10 years. The expectation they're going to last much longer than that. So literally doing the math, and I, again, would need a return on investment calculator from a homeowner's perspective, they literally pay for themselves in less than 2 years. Okay? 2 years. Because an average, let's say a 50-gallon electric resistor element water heater, pre-2015, okay, because there was a thing called the North American Energy Conservation Act that all the efficiencies mandated by the federal government had to increase. But those are the units that are being replaced today. Okay, so if you were going to look at that, a 50-gallon electric water heater typically is going to run about $565 to operate a year. A Proterra, that's what we call our brand. We have several brands in the market because we're in a variety of different channels. You could expect, if it's in the heat pump mode, which we'll talk about $105, $104, $105. So literally you're saving $300 to $400 a year in energy costs. Over a 10-year period of time is minimum $4,000. That's significant. I mean, for me, it would be significant. I know my kids would be happy. Okay, condensate needs to be neutralized. Now, where there's warmth, where there's heat, there's moisture. Now, I'm a Midwest guy. I've been born and raised in the Midwest, even though I live in St. Louis. Some people consider it the Midwest. I've been up in this area forever. Most have basements, unless they have a home that's in the 70s, it's on a slab or something like that, right? But what happens in the summertime? Who has dehumidifiers? Who has whole home dehumidifiers, right? The way a hybrid heat pump water heater works is that it captures that residual heat, but it also captures that moisture. So when installing this, there's a condensate line that flows from that unit into a drain. So in essence, depending on the size of your basement, you likely would get rid of your dehumidifier because the water heater is doing it for you. So another significant savings in regards to operation of this unit. Okay, I don't want to run out of hot water on this. A hybrid heat pump water heater provides more hot water than a 50-gallon, 50 to 50, more than a standard 50. In fact, you're going to get 6 to 8 gallons more first hour delivery on a hybrid heat pump water heater. Why is that? The tanks are the same, right? Well, because you have 3 ways of heating that, you have 2 ways of heating that water. You have the hybrid or the heat pump portion of it, which is generally the primary source of heating the water, and then you have the element backup that rotate back and forth. Because typically this unit is never going to draw at any time more than 30 amps, which is a standard, what a typical electric water heater would do. Okay? Now, if someone had an electric water heater, that makes no noise unless it's full of sediment and it starts popping and stuff. But now it has a heat pump, so how loud is it? Well, I'm proud to tell you, I mean, we have the quietest one at 49 decibels. Now, what does that mean? What is 49 decibels? By the way, this is probably 300 decibels, me talking over this microphone. Okay? A normal conversation is around 100 decibels. So it's fairly quiet. Okay? So, that was just the first page. Aren't you guys lucky? Okay? So, you know what? I can show you some emails I just received today. And there's a lot of people out there, you know, we have a very extensive contractor network. And we've been working diligently making sure that we're training them on installs, because I hear from homeowners, well, who do I call to install it? Who do I call and install it? So we reward them, you know, as if they're a REAM, what we call a pro performer or whatever. But here's the thing. Nothing's really changed, and I'm going to tell you from the perspective of a homeowner or whatever, is that there's not much difference with a hybrid heat pump water heater than a standard electric resistant type for the installation process. Because typically it installs no differently unless you vent it, because these can be vented. Water heaters can be laid down on their side. Plumbers are, the first ones we had to stand them up because the compressor, and that would be just, guess what, we made them so robust you can lay them down. Can be mounted against a wall. Now, why is that important? Because manufacturers realize that if something needs to be worked on, you need space, you need clearance. So that means you can put this in a closet, provided it has access to 700 cubic square feet of air. Now, how do you do that? If it's in a closet, well, you put louver doors in, right? Zero clearance. The only difference is you need 6 to 8 inches at the top, because there is a media filter that needs to be removed to remove any type of lint, dust, or things that accumulates as it's drawing in air. Well, homeowner, well, how am I going to know when it needs to be cleaned? Guess what? This unit will tell you, because we actually have an app that you can download in your phone, or it'll give you an audible beep, clean your filter. Okay, so it works properly. So it's 100% plumber serviceable. Okay. So I mentioned earlier Proterra, so pardon me on that. So we built this model, what I call the 3 pillars: smart, sustainable, and savings. And you're going to hear in this, you know, there's a lot of savings. Obviously, we talked about that already. So let's talk about what smart means. Now, utilities love this product because it gives them what they're looking for to help the homeowner. So what is it? Leak guard, automatic shutoff. And it has leak sense. If you've ever had a water heater go out, okay, what happens? You're not getting enough hot water, or it's leaking, right? So this unit will actually tell you if there is a leak. It'll give you an audible alarm as well as on your phone. But it will also shut the water off to prevent any type of damage that you would have when the water, you know, and some of you may have experienced that. Okay, and I know insurance companies love that. So you may want to look into that. Integrated Wi-Fi, we call it Econet. So this unit can be connected. Okay, you can hook it up to your phone. You can control this unit yourself. Remote control, there's the phone. Compressor and element health. This unit will tell you the elements need to be replaced. You're starting to develop scale on the inside of your tank. It's not working efficiently. You need to call a contractor. It will actually tell you a text send you a text or send you an email, depending on how you set it up. Not only that, but it will give you an audible alarm as well. Okay? Now, my favorite is hot water availability. Anybody that's got young kids realize that you never want to be the last in the shower. Okay? I've been caught in that many times. So it will tell you. It won't tell you how many gallons you're going to have, but it will tell you, hey, maybe you need to wait a little bit. It's recovering. Take about a 10, 15-minute break, and then take your shower. So now, I gave you a picture of the screen. Wow, this is really close. This actually is what you would look at from a homeowner's perspective, so it's very programmable. I'm not going to go through the sequence of how to do this, but I do want to touch on the modes, okay? Of how you can actually program this unit to operate in certain modes. The first mode is energy saver. Now, energy saver mode is that your heat pump is a primary source of heating that water. The elements are going to be secondary. If the unit is sized properly, your elements likely will never come on, okay? Now, we have them in a variety of sizes, which I'll go into in a minute. So there's the heat pump mode. Now, you can actually program this unit to only operate in heat pump mode. That means the elements are taken out. Now, I probably, unless it was a 65 or an 80 gallon in Michigan, probably would recommend against that, because the temperature of your water typically drops significantly down to 40, maybe 38, 40, 42 degrees in the wintertime. Okay, so if you know that you're okay with that, then if you give the heat pump enough time to recover, then heat pump would be the mode to go in. We have the high demand mode. Let's say, for instance, you have programming that to be, heat pump only. But you know it's the holidays, you're going to have people over, people are going to take more showers. In the wintertime, you take longer, hotter showers. Okay, now you put it in high demand mode. Okay? So what that means is that the heat pump's operating, not only the heat pump, but you're also going to have the elements really operating simultaneously. Not together, non-simultaneously, but with the heat pump. Okay? Then you have the electric mode and vacation mode. Now, the one thing I'll tell you, it's a smart water heater. Built on your usage, it will actually learn your behaviors and built-in algorithms within that unit. So it will start heating if it notices that you continually take showers at 6:30 in the morning or 7, you will have a hot water as needed. If you take them in the evening, it'll make sure you have that. Okay? So it is a very smart heater. Now, let's say you put it in high demand mode, but you forgot to set it back. Well, guess what? In 10 days, it's going to revert back to energy saver mode. This unit will continually go back to the default mode to save the homeowner money. Okay, so it's a smart water heater, without a doubt. So those are the modes, and you have a way of doing that on the phone, or if you download the free app through Ream, or you can do it manually in front. Okay. Now, the next, I can't see, it's getting dark out here, but I think it's, 7 or 9. I think it's 9. I gave you a screenshot of the app, okay, of what it looks like. And I'm not going to go too much in depth with this, that's why I left you a copy. But there is a scheduling feature and a usage report that once you download on the free app your water heater, you can actually schedule this unit. I'm going to take it one step further. When you know you're not going to be around, you can change the temperature of that unit down. When you know that you're going to be showering later in the day, you can turn the temperature up. What are you doing? You're saving money. There are 4 different spots in the course of the day you can actually manage that unit for energy consumption. Okay? Now, that's what utilities do. That's why I mentioned in the very beginning you have peak and non-peak. Okay? So you are taking it one step further proactively as a consumer that the utility would be doing. Okay? Now, just out of curiosity, let's say you want to see how much energy did you use. Well, you can go on your app and you can pull it up. It's going to show you on a weekly and monthly basis how much energy you're using. That's what utilities look at. You'd be surprised if you go into their rooms, they see these graphs. That's how they adjust their rates. That's how they make adjustments. Now you have visibility specific to that water heater, and you're going to say, wow, it really spiked up. Well, guess what? That was Christmas. A lot of people are taking showers, right? So again, that has a lot of ability in these units to do that. So now a couple other things, sustainability. And this really kind of goes to what's going on in regards to the environment and things like that. It is the highest efficient water heater in the country. We have an 80-gallon that goes to 4.0. The standard 50-gallon electric that you would get with the resistor element typically is going to be around a 0.93 or 0.94. Mike was talking earlier about the COP, right? Put $1 in and get $1 out. Well, guess what? You put $1 in, you get $3 out. Okay, that's what it pays for itself. It's crazy. Okay, carbon footprint reduction. If the utility does not have to generate excessive energy, they're not putting more carbon-based fuels in order to do that, so it's better for the environment. Energy saving tracking, I already showed you that in the app, right? And of course, Energy Star. Now savings, this is the one I get excited. I get excited about everything, right? But saves time, saves money and energy. Energy saving schedule. Built-in demand response. Now this is a utility term, demand response, because these units are equipped and you already have connectivity to it to do what they're ultimately, when you, like for instance, do any of your local utilities run any type of thermostat programs like Nest or things like that, right? If you give it like $75 a Nest, but there's also provisions in there that these are connected, right? So these units, the Proterras, much like others, have certain features that they're able to be connected as well. Not just through your thermostat, because a thermostat in a home will not control the thermostat on a water heater. Okay, so that's kind of the long play here. It's going to tell you what's going on. And then, okay, this is where, again, proof is in the pudding, right? So I actually put energy, if you've bought an appliance, you'll see that there's an energy guide on everything. That's mandated by the federal government, Department of Energy, right? So I use a 50-gallon as an example. This came right off the line, these examples, okay, off the manufacturing line. So a Proterra heat pump mode roughly going to be 867 kilowatts per hour, per year. Doesn't sound like a big number, does it? Well, if you can see the next one, it's like 3,500. That's a typical 50. So you can see the cost savings in energy usage just by the energy guides themselves. I'm not just spouting it off. Now, the one thing I'll tell you, I did an electric to electric. Okay. Now I know in the Midwest, big gas, right? I know Brett talked about fuel switching and things like that. Totally get it. I mean, we make both, right? So I got to be careful. But the Proterra is less expensive to operate even than a comparable 50-gallon under-fired gas. I'm not going to get into specifics. And if you talk about LP, that's a totally different conversation. Okay, so again, it's the most efficient product out there. It just happens to be electric. Now, I have the product lineup on here because it's getting kind of dark out here. I don't know if you can see this, but we do have a builder model. We do have a Proterra, and we have a Proterra that has the leak guard and everything else provisioned with that. And it has some of the things that's there. Now, on this handout, so you know, I have my contact information. If you have no, if you have some questions now or ever later, don't hesitate to reach out to me. But I've also put some slides about how it's installed. I also gave you on a couple slides of how you can actually vent these units, because some people are concerned about, well, it's going to take the heat out of my house. It's going to make my basement cold. I don't want that in my house. You know what? It is going to drop the temp, but it's going to drop 3 to 6 degrees. okay, where it's installed. And any geothermal guy will tell you, especially in the Midwest, is that what heats your basement isn't necessarily as much as the furnaces or the boilers or whatever. It's the residual heat coming in from the walls as well. Pretty accurate? Yeah. So you get some of that in there too. Of course, you know, depending on the size. So if you're a very small basement, yeah, you're going to feel it. But the cost savings is more than makes up for it. Okay. So I'm going to open it up now for any questions that you may have. Oh, please. Yeah.
Yeah. Okay, great. Thank you. I think what we're going to do right now is have questions for Tim for sure, but also because it's getting late and dark, even colder, we're going to have Mike come back up if you're somewhere. And Wayne, this is Wayne Appleyard. Wayne is a architect in town, and he has a net zero home. So he heats with all electricity and has no gas. So he's here to answer questions from a user's perspective. Julius, are you here? Julius is our intrepid IT liaison for the Office of Sustainability. He looks miserably cold. Thank you for Julius thought he could call in and answer questions, and I had to text him and go, oh no. So anyway, Julius actually has one of these Ream, right? Ream, Julius? Oh, Julius has this product in his house. He just got it recently, so he can tell you how it works. I haven't asked him or pre-vetted that, so hopefully it works well. Oh, okay. And then, Claire, are you here? Come on up. I'm going to have Claire introduce herself very briefly. Claire is from the Seas School at University of Michigan, and they're doing a little a research project around heating and heat pumps. And I'm just going to give Claire 2 minutes to mention what that is, because then she can also stand here and answer questions if anyone's interested in being part of her research. So, so Claire for 2 minutes, and then we will, I guess what we'll do is we'll have people ask questions, and certainly I think there's a lot of questions in the Zoom, and we'll go around and make sure if you're a speaker answering a question that you repeat the question if it's coming from the audience. Okay, here's Claire.
Hey everyone, I'm Claire McKenna. I'm a resident of Ann Arbor. I live around the corner, so this is very convenient for me. And I can't believe I zipped the insulation out of my jacket before coming. So mental note, that was the worst decision of the week. I am super new to Ann Arbor. I'm coming from a career as a building engineer, having designed all electric and sustainable buildings for that time. I'm a building scientist now at U of M in the School for Environment and Sustainability, and I'm starting a study called Heating with Justice, where we're looking at the societal impacts of at-scale deployment of heat pumps for residential. And so one of the biggest concerns is that the energy cost, so what the cost that everyone's going to pay for heating and cooling is going to get higher overall. Sorry guys if you're selling heat pumps, but it's definitely a concern when we look at the impact of the utilities and how the utilities might respond with more dynamic and higher electrical loads. So the study is currently ongoing. We're recruiting now. I have some information. You can meet me in the back and talk about potentially signing up or getting more information. But yeah, that is happening locally, and we're looking at Washtenaw and Wayne counties first. So like this is really local, and it's about to kick off. So we'd love to have you involved. Free energy audit, that's right, free energy audit, and $200 if you let me come to your house and install a smart thermostat so I can read your internal temperatures. Okay.
Thank you. All right, so I think what we'll do is, you want to start here? Is there anybody who has a question for Tim or anybody else? Yeah. Heat pump water heaters versus solar. You have a solar panel water system. Do you want to answer that, or do you want?
Yeah, okay. As long as it's not on a current load control program that's approved, you probably could do that, because what you're doing is actually you're using the water heater as a battery. Okay, you're dumping hot water into the water heater, and it's only going to lose 5 degrees in like 36 hours. Okay, So, but if you're going to a load control program and you get an aggregator that does on a grid system, that's a different conversation that we'd have to have.
I used to install solar water heaters, so if you have a separate preheat tank, it'll work finely. There won't be any problem at all, because what you're doing is you're heating up cold water. It comes in from the street to whatever it can, and then it goes to the heat pump water heater. And the heat pump water heater has a thermostat on it, so it's going to shut off at a certain temperature. It's not like a one-through gas unit that may require, may not work if the temperature is too high when it goes in. It may sort of have a tendency to overheat the water, although most of those have figured that out. But so you shouldn't have any problem at all.
Thanks, Wayne. Oh boy, hands. I think I saw you back there next. Hi. Are you talking about air heating or water heating? Water heater with a hybrid gas backup is the question, as opposed to a hybrid water heater with electric resistance backup, correct?
That's a very good and timely question. I can't comment on it. I cannot comment on it due to NDAs we've had to sign. But I like where you're going with that.
Sounds like maybe someday. Yes. So to repeat the question, he's asking if the hot water heaters, heat pump hot water heaters, can be act kind of as a battery storing energy, correct? Okay, Wayne or
Wayne, do you want to field this one?
I'm not entirely sure what you're asking, but you're storing energy in hot water, sure. But are you trying to use it to produce electricity or something else? Okay. That's basically a time of day thing. So what you're really doing is saying you heat this up, you put in a bigger tank, maybe a 100 or 200 gallon tank, and you heat it up at night when the rates are low, and then you run it through coils in your house to heat your house during the day when it would cost more if you were running it directly. Sure. There's Saul Griffith and his other lab is working on getting that out into the marketplace. They spun it off into something that I don't remember the name of right now. But
Actually, to add to that, they've been doing that for decades. The National Rural Electric Cooperatives have been using load control for the last 30 years, keeping their members low rates and turning them off. And you know, it's a whole, and it's growing.
Andrea. Ooh, that's specific. Can an air source heat pump and an air source water heater coexist in a utility closet in a small space, basically, with louvered doors, main floor, no basement?
Is it on the left or the right side of the hallway? So the air source heat pump, as long as you can fit that air handler in there, which it is a small footprint, we got to think about when you're talking about an air handler. The air handler itself is, we can tell you the exact dimensions. It's your ductwork around that, right? So that generally, if you got a drop and I'm coming up the side of the return drop, that's the size you got to look at. Living or coexisting with the heat pump water heater is no problem. We don't need the louvered door. So it's just, is there the space? I have some applications and some pictures I probably have them on my phone I can show you of air handler and a heat pump water heater in the same location. You should probably have no problem with that, as long as the height restriction is fine.
Really, you gotta have 6 to 8 inches on. Oh, excuse me. You have to have 6 to 8 inches on the top for clearance to get the media filter out, and as long as it has access to 700 cubic feet, square feet, you're good. It's just airflow. What's that? Yeah, louver doors is like not having a door. I mean, it's aesthetic. You just can't see it, right? So, yeah, it should work.
And to the Zoom people, the one thing we didn't think about was lighting. Sorry to everyone. Anyway, next question. Yes. So the question was, at 10 years or after, whenever, what is the main way that they fail? What goes wrong? And I forgot the second part of the question. And do they come standard with magnesium anodes?
That is an excellent question. Thank you for asking that. I did mention it as a 10-year warranty, but I also said that the expectation is to go farther than that. Now, the one thing I'll also tell you, and there has been hesitation with this, well, what happens with the heat pump? Mike talked about, he had a Zoom call about what type of refrigerant. I'm glad I didn't ask that question because I couldn't answer it. And here's why. If something happens to that heat pump and it's verified that something went wrong with that on the heat pump section of that heater, you get a new one for the remainder of the original warranty. You don't have to work on it. Done. As long as we verify it. Now, what can go wrong on the heater? Well, potentially the control board, which anything that high tech, that's always going to be an issue, potentially, or elements. That's it, really. Now, water quality is the devil to a water heater, right? Believe it or not, you look at any installation manual and say, flush that unit every year. Yeah, who does it? I don't, right? I've been working for almost 28 years. So that's what you can expect. If you maintain your water quality, if you lower your hardness to an acceptable level, I mean, if you're on city water, good. If you're on rural water, okay, then you should probably have that measure. So that.
Julius, I'm just curious, because this is my question, sorry. Do you have your heat pump water heater in your basement? Yes. Do you notice it being colder around the water heater?
So I have mine in a utility closet, and you only notice while the heat pump is operating. The heat pump does not operate that frequently unless you're actually using your water. So I would say that the temperature drop is, for the most part, going to be unnoticeable. At least that's been my experience.
That's really good to know, because I was really curious about that. Yes. Whoa, are you an engineer? So the question is, if you have both, if you install both a water heater, heat pump water heater, and air source heat pump at the same time, can you connect them together so that in the summer you can use some of the excess of one to sort of help the other? I think the answer is if you have geothermal.
You're dealing with a lot of things here. You're talking about air source, you're talking about hydronic heating, you're talking about a lot of things here. Okay, and that's not a road I'm going to go down.
You can't, in essence, you can't just take that water heater and our systems and tie them together. That doesn't work. Stay tuned for that as technologies progress.
Or feel free to get a patent. Yes, sir. Quickly, and yeah, and then we'll go to the Zoom people. Yes. There you go. A suggestion of putting your air source or your heat pump water heater in the same place where maybe you want it cooler, or with a second freezer, and so they can work together. Yeah. Question. Can you install your own hybrid water heater?
Really? Can they ask me that question?
We always we always recommend contacting the trade to do so. We can't control if someone, an average homeowner, install them themselves.
So warranty issues, yeah. Zach, do you want to let us know if there are Zoom World questions? And we have an intrepid Zoom audience too, even though they can't see anything but our dark shadows. Hi guys, they're still there. Oh God, okay. Thank you. Is that Mac? Okay, here you go.
I meant quickly get the patent, by the way, not quickly with the questions. Okay, is Mitsubishi offering any air-to-water systems in the U.S.?
Commercially, on our three-phase equipment, we have some newer air-to-water systems. On residentially, on single-phase, not currently, but we are in process. We have a product called EcoDan that has been out for a very long time over in Europe and other parts of the world that we are working on getting over here. Would have been here a little bit sooner, but some things happened over the last, year and a half that have slowed some things down. So air-to-water is coming for the residential market through Mitsubishi products.
That's fine. What about free consultation for sizing and installing heat pumps?
So that would be done through contractor. As a manufacturer, we can't do sizing from that aspect, but I mentioned earlier how to find our contractors, MitsubishiComfort.com. Reach out to the contractors for sizing and system selection.
The cell phone lighting is helping, I think. There have been a number of questions about getting materials from tonight, so such as brochures and whatnot. Are we able to get electronic copies to Julie and then get those out to the Zoom folks?
I sent a link. I don't know who I sent that to. Somebody got a link, but we will have that for a link to download the exact brochures that everyone here in person has as well too.
All right, cool. And then also for the Zoom folks, I've dropped Claire McKenna's contact info into the chat as well. Let's see, there were some questions about the water heaters. There were just some general questions about the noise levels of the heat pump water heaters for gas versus electric. And on a similar note, what's the payback for gas versus electric?
You won't notice the noise. If it's running and you're standing next to it, you can tell it's running and you're standing next to it, but it basically sounds like a low-level fan, and that's only when the heat pump is operating. I would say that that's louder than a gas-powered water heater. That's what I switched from, but I mean, it's negligible, so.
Well, the payback period specifically on the Proterra, which is the hybrid heat pump water heater, typically you can expect the payback period to somewhere be around 2 years based on a 10-year warranty period. And that's not even taking into account any type of local rebates or things of that nature that you definitely want to look into depending where you're located. And it does have a $300 federal tax incentive this year, and we're expecting that to carry into next year.
Excellent, thank you. Okay, can you take a 2-zone house and take one of those zones of the furnace and throw it out and make it a single-zone house with gas backup?
So I got a 2-zone. All right, I got a 2-zone house on a gas furnace, and take one of those and throw it away. So it's ducted off of a 2-zone duct system. So a zone duct system is what I'm assuming they're asking for. So you can install an air source heat pump into part of a home. and leave the furnace for gas backup. That happens a lot. So you may think of a 2-story home, for instance, where I have a furnace that's ducted for the entire home. A lot of what occurs is the second story of the home is not a heating issue, but it's a cooling issue. It's very difficult to cool. If anyone lives in a 2-story home, your second story is hotter than your first story. I don't even have to know about your house. And that happens a lot where a Mitsubishi system and air source heat pump is put in to take care of the cooling problem on the second floor, but it also maybe put in a cold climate air source heat pump to heat and cool the second floor. And then your furnace is left for heating the first floor and cooling the first floor and a backup for the rest of the house. I think that's what was being asked, something similar to that. So the answer is yes, in a way.
Great, thanks for taking a stab at that. What's the difference between a Mitsubishi heat pump that has a COP of 2 and a COP of 4?
Heat pumps, because we are reliant on the outdoor air temperature, is going to lose efficiency as it gets colder outside. So you may have a heat pump, a specific model that has a COP of, these numbers are not accurate, I'm just throwing them out there, a COP of 3.8 at 47 degrees, but it might have a COP of 3.1 at 17 degrees. It goes down. So there isn't really a difference. You're not getting a heat pump and saying, oh, this is a COP of 2 versus this model that's a COP of 4. They're all high efficiency, but you derate as you get colder outside. So that's the difference with the heat pump in terms of efficiency. It does go down as it gets colder. COP is coefficient of performance. It's how you measure all electric heat. What are the water heaters? 4? Did I hear you saying that? COP of 4? Did I hear? I don't remember. Maybe I didn't hear you say that.
I see you. So as the efficiency goes down, do you, what? You repeat that question?
So the question was, we were talking about COP. As the efficiency of a heat pump goes down, do you feel it in the house, or is it more of a cost? It's an efficiency. It's not necessarily, you don't feel that, right? So we talked about a cold climate air source heat pump. If I'm putting out 36,000 BTUs at 47, but it's a COP of 3.8, I'm still putting out 36,000 BTUs at 5, but my COP might be 2.8, right? The comfort's the same, but my efficiency has dropped a little bit. Is this a relation question to that? All right.
So the question is, how is a heat pump going to feel different in relationship to, say, a radiant wood stove or perhaps a gas fired furnace? And I had an oil-fired furnace, and I swapped it out. I put in an air source heat pump. And the thing that amazed me most was how more even the heat in the house was, and how I grew up in a house with radiant floor heat, and it almost feels like I have radiant floor heat now because it's subtler, because it runs longer, but the temperature coming out of the ducts is lower so that you don't even notice that it's coming out of the ducts, really. The other end of, the other part that you were talking about is a wood stove, which radiates heat. And that's a totally different animal. It's only going to work where you can see it, basically, for the most part. You go around a corner, and the radiant heat isn't going to find you except to a lesser degree by if the air's been heated. So the high level of noticing that you get from a wood stove, you don't get from snow. But what you get is an overall very comfortable feeling in the whole house. My wife, for several months afterwards, kept going out of the house with less on than she should have on because she thought it was warmer out because the house was more comfortable.
That's a perfect point. When I was referring earlier to that thermal comfort, right? That's a big difference. It actually feels much warmer. I was looking this up because this is an old picture I remember, but this was a contractor sent me this when it was minus 13 outside, and this was output at a ductless wall mount unit of 116.6 degrees. It's not blowing 65 to 70 degree air out of the heat pump. This was putting out 116 degree air out of the ductless heat pump at minus 13. It's pretty significant.
One more, which is, what happens when there's a power outage?
Yeah, you lose power in your home.
Yeah, so there's a little bit of a misnomer, but when you have gas, you also lose that during a power outage because you need from a gas water heater. It takes electricity to run, at least except not necessarily the older ones maybe, but the power vented ones that you should have to keep you safe. And then of course the furnace takes electricity to push that air out. So those are out, just like the heat pump water heater, just like the air source heat pump. Everything's taken down. But the big difference is, of course, is in the middle of wintertime if the power goes out, then you've got a concern with the heat pumps to some extent because they use a lot of electricity. They just use more. And so obviously if you've got that backup generator, you can keep a gas furnace going, a gas water heater going, and there are generators that I think are large enough to handle the air source heat pumps, and especially the air source water heater. I mean, that's very minimal energy, even in the winter, so that may even be a moot point. But yeah, everything. When the power goes out, the power goes out. Everything's out. So I don't know if you want to add any more to it. But.
Actually, I do. On the hybrid heat pump water heater, don't forget I've said it several times. It's like a battery, so you're gonna have a full tank of hot water. If power goes out, provided it was hot, you're good. I mean, you can let it go all weekend, you still have hot water. And then if the power goes out and you programmed your hybrid heat pump water heater with different modes of operation, there's a battery in that unit that saves all that information. So when the power is restored, you don't have to reprogram it at all.
So we have a few more minutes, and I really forgot it was dark at 8. It was dark at 7:30. Thank you for correcting me. This is fun. This is like our first hybrid event, so you guys just rock. Whoever's still here, you get some prize. We haven't figured that out yet, but I'm sure we will. Yeah.
And same to those on Zoom. We still have 30 people that are watching on Zoom. That's about half of the people that started, but still very impressive. Thank you all for lasting this long. I think I've only got one more Zoom question here, unless any come in at the last minute. But there was a question earlier about what kind of electrical draw there is on these systems. This one is a little more specific. If you swap out a gas furnace to a heat pump system, what sort of provisions have to be made to the service panel specifically? For example, does it need a dedicated new circuit? Because there are a lot of the houses that are built in the 60s and 70s only have a 100 amp panel. Would that require an upgrade?
If you do not have electric resistance backup heat, the electric heat kit, then no, because the difference with a furnace and air conditioner is the furnace has a run from the panel and the air conditioner has a run from the panel. The difference with a single zone air source heat pump is that you power the outdoor unit from the panel, and then the outdoor heat pump has a wire that powers the indoor air handler. So there's not a separate run from the panel to the air handler unless you have an electric heat kit, right? If you have the electric heat kit, you need the separate run from there. So it's actually less power requirement dependent upon the size of the heat pump system in relation to the size of the air conditioner that is there currently. But you should have enough power there to handle the heat pump unless you have that backup electric heat kit. That's going to be something separate on its own.
I didn't know that. That's a good question. Yeah, I see Andrea. So the question, yeah.
Probably not going to be enough.
Yeah,
depending on the amount of heat kit, it's probably not going to be enough for that heat kit. Not for the system in general, but for the run that's there for the heat kit, it may not be enough. But you may just be able to change the breaker size, you know, at the panel, depending on the wire that was run. That's an electrician question more so than this. Don't follow what I say.
Don't listen to any of these people. I think we have time for like maybe one or two more questions. Yes. So the question is, with an air source water heater, with a heat pump water heater, do you advise venting the cold air out or into a duct?
You know, there was a study done in the Pacific Northwest that they determined that less than 5-6% were actually ducted because people did have enough room. But there's a reason why we allow it to be ducted. Some people don't want that perception that they're going to get cooled off, or maybe the reality based on the size. So you can vent it up to 125 feet. And you can draw in air, you can take the air out. If you so choose. And to your other question about the ducting into the cold air return, yeah, it's fine. The whole idea is just to take that cooler air and put it somewhere else where it's not gonna, or get diffused a little further out, not just in one area. So you're good.
Of a duct system, now you have colder return air that you have to overcome. That you're heating up colder air. Then right, yeah, and it's great. Yeah. I want a flapper.
More engineers. I think Zach has one more question from Zoom.
All right, and we're going to try something new here. Matthew Raphael, you are allowed to speak. If you just want to ask your question, let's give it a shot.
Okay, hey, thank you. I just want to know, forgive me if you already covered this, but what kind of heat pump system would you recommend for a radiant floor heating system?
That was the coolest thing ever.
So we talked about it a little bit earlier. I don't know if our boiler home people are still here. I can't see anybody out there anymore. But if you have a hot water heated home, or even whatever type of heated, whether it's in-floor or radiant heat, you can still utilize a cold climate air source heat pump. The difference comes with the types of indoor units that you'd be looking at. If you have the capability to run ductwork, great. We can run some ducted units. If you don't, that's where ductless units will come into play appropriately throughout there. Now, if you want to keep that in-floor radiant boiler system in the house as a backup, we can integrate that from a control standpoint into having that boiler be your backup and having the cold climate air source heat pump be your main source of heat. And it can engage that boiler when needed if you don't want to get rid of the boiler. So you ideally, most likely, it's going to be ductless or some ductless combination, because you probably don't have room for ductwork if it's a boiler heated home. But we can make them work together if you don't want to get rid of the boiler.
Thank you.
I think we're done. You guys are amazing. I'm guessing some of these guys will be standing here for at least 30 seconds or so. If you if you wanted to come up and mingle and ask questions. I can't tell you guys, you are amazing. And really, thank you to the Zoomers and whoever's watching the recording and all of you for putting up with this attempt at hybrid, which I think had some successes and some challenges, but you know, this is what we're going to do probably moving forward, right? Is some in person and some Zoom and some hybrid. So anyway, thank you from OSI. Thank you from me personally. Thank you to our speakers and presenters for coming out in this crazy venue. Thanks all.